Um, okay, yeah, it automatically understands strings. Anyway, this is we're dealing with vectors here, and that weird little class thing here that pertains to this because we're going to be storing objects in vectors. Um, this shows vector that holds strings. And again, this idiot doesn't need to put string there. I mean, just put a goddamn save yourself some fucking typing and just put the goddamn literal. I mean, a literal is a literal, so don't worry about it. It converts it into strings because it's expecting a string object because we define it in the template here. As being having accepted strings, so there's no reason to do that. That's redundant, and it's just a lot more garbage on your screen. So, but vectors, as you might have figured out, use templates. They're part of the template class in C. So you create a vector object. When you instantiate a vector object, you pass it in a template value in the angle brackets, and tell it what type you want it to work with. As you see here, it can work with many different types, including objects. So, basically creating a vector, we're pushing some data onto it, namely these 4 strings. Um, I'll put that one in there too, just to verify that works. Um, and this is basically accessing the data laterally, so that we, without popping anything off of it. But it's basically creating a form of a stack, so that you can access the members, directly without modifying the stack as well. You can peek at them. So, and here we're kind of doing the same thing with integers, pushing it onto the back of the stack and got lucky numbers. And here we're creating a couple of employee objects, and it's interesting how we're sending those in there. Wouldn't you agree? We're not using the new keyword or anything. We're just actually saying employee, which is the type, the class type, and then we're passing in data to its constructor. So, but it still will create a reference. I don't know what kind of reference these would be, but I don't know. I'd assume they'd be pointers or something. Um, but we are able to access it laterally, just as if it was in an array, and access its names directly. But we would have to, go through this vector object to do that. So, but this is still another way outside of mapping, because a map is, again, kind of in the same class. Because a map, we can actually have return an actual pointer, whereas this, it's not storing pointers. However, we might be able to have it store pointers. I don't know. So, I mean, I assume you could. But this is simply, storing employee objects. I don't know if I put a pointer reference there, if that would work. I mean, I know they would have problems down here. So, yeah, it might. So, because then you could have it return a pointer too, maybe. If it was storing pointers, it would return a pointer. But here we're actually storing actual objects in the damn thing, so we can actually access its objects directly like that out of the array. So, but you can also, there's a lot of functions, um, workers, right, workers, um, dot assign at, you got a lot of functions available to you, for dealing with, with these objects. So, um, including size, push, and pop, etc. Um, end, empty, pop back, push back, so max size, etc. So anyway, the point is that just look at the references and out in the net, and that'll get you settled. Run this stuff at Turkey, and so basically, that's what it does, and there's the thing that I added to it. So at the first of the video. So anyway, it's pretty straightforward. So let's pull up the next file, which I have a feeling might have something to do with the same topic. Open Dummy 6, which is the last in the Dummy series. Okay, now this is an interesting one. It has to do with queue objects and stack objects, and it does have a vector object too. But now I needed to go look at something. Let me open the project and go back to I guess it was Dummies 3. I just needed to look at something real quick because we use the map object in here. So yeah, so you got to actually include the map library if you want to use the map function. So but here, queues and stacks work in similar ways. Again, look this stuff up on the internet, but this is at least one practical example. But if you notice, let's see, void stack demo. So these are functions here. I create separate functions for each of these. But we declare, basically a my stack this way. We're passing a vector into it, though, interestingly enough. This function doesn't return anything or accept anything, so remember the space between that. So yeah, because it'll look at that as a it's one of those stream operators if you don't. But at any rate, so it's a stack, and we're defining it, with integer and a vector of type integer. So we're calling it my stack. It's my stack push, 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 and then we're popping some values off of it. And again, I'm not going to cover this stuff very thoroughly. Just look it up. But this is in particular, this is peculiar. So that we're because a stack object, I don't think you have to pass it a vector object. I don't think you have to create a vector in there. That's kind of weird. It's like queues. I know you don't have to do that. But again, I'm not even quite sure on the declaration syntax. In other words, we're passing in an integer and then something else. Well, what does that have to be? It's looking for, well, maybe you do have to pass it a vector object. I don't know. That's strange. Yeah, it's acting like you do. But so I'm not quite sure what we're accessing. Okay, it's got to be the stack object, but what are we popping off of it? We're pushing 5, 10, 15, 20. Then we're popping some values off and pushing some more values on. and looking at the top and popping it, but I don't know if we have lateral access or not. See if we do. No, apparently you can't access lateral members. In other words, it acts like a traditional stack, apparently. Because a traditional normal stack, you actually can't view things laterally like you can with a vector. And with a vector, you can, put those, brackets in there and treat it like an array and actually peek at the data in the stack, laterally from the side. But in a traditional stack, you actually can't. You can only push or pop. That's why I can never understand what the usefulness of stacks was, because I was like, shit, that's kind of limited. You got to pop data off of it to even look at it. But anyway, the point is it may not work that way. I mean, more research has to be done. This is just out of a book, and I was in a hurry when I typed this in. So, if you want to look at these various structures, they're all kind of similar. So, no container specified on the queue, so it uses DQ by default. The same goes for stack. So apparently you don't need to specify a container in a queue or a stack, because I guess the container was the vector, up above. So we're just basically saying queue integer. Let me see what the standard queue int. So yeah, you can specify a container too in this. So you got the option of doing it that way. But yeah, so you can define a stack just that way too. So I'm not really sure about the container, but I mean it'll, probably my stack, or dstack or whatever, would be the default. So you'd have to look up, again, the intricacies of this, the nuances, again, without going and rereading the book. But it's just easier to look this stuff up on the internet and to get the most current information and find, useful examples instead of the crap you find in these stupid books. So yeah, just, look it up out on the internet. But this is all this does. It just runs these two functions. So let's see what it does, and then we'll conclude this lesson. So anyway, you can see kind of what it's doing there. I'll scroll through this so you can correlate that with what you see on the screen there. So queue demo and stack demo. Got it? Get it? Got it? Good. Alright. Now, that'll pretty much conclude this lesson then.